back. So I support that.
Thank you.
Right, can we start the recording? No, it looks like it is.
Yeah, no, you just started. Thank you, Sinawu. Go for it, Gerard.
Okay, so today there's 4 steps left. And let me do my thing here. And go back up to the index. So we've looked at the application, how to evaluate it and get to the either 1 or 2 quotes, depending on your philosophy. Yesterday, we spoke about the contracting, and like Mark said this morning, it looks very daunting, but I think the connection agreement is really the important one. And when customers come, they want wheeling or anything else, then one can deal with it from there. Design, we also discussed yesterday. The key takeaway there is that on the distributor side, the design is following pretty much the standard process or the existing process. You might have to add 1 or 2 extra components if you want to do, like Andrew had mentioned, with the sync check, with the synchronizing relay. Andrew had also shared his experience with some of these aspects in implementing it with real generators. So then construction, commissioning, grid code compliance, and closeout. This morning, construction and commissioning is what we're looking at. And in my opinion, there's not really too much to say for the distributors on these 2 either. The grid code compliance is the next presentation, and there we have a little bit more to say. And then the closeout. Sorry about that. The closeout is also not the difficult part. So let's look at construction. Obviously, all the designs and everything that we've discussed so far, that has to be completed. You've gone through your technical and financial approvals, and then you can start with the construction process. It's very important to remember that all the approvals needs to be in place. If you are outsourcing any of these steps, it's good to ask for them, how do they handle the approvals and the quality assurance? So that would be part of the contract with them. They must, it's like a ISO 9000 certification, or at least a statement that they comply with the requirements, because not all companies are assessed against ISO 9000, but you can still apply the principles. And once again, with the design, just as with the construction, as with the design, there are 2 sides to it. There's a part that the distributor would do, and then the rest is the generator and their responsibility. So looking at the distributor side, metering, we know, is always going to have to take place. Okay, unless you already have a 4-quadrant meter installed, then it just depends on whether it's the correct size. Also, it's always advisable to look at the protection. So just give me a moment. Okay, so the protection needs to be checked and verified that nothing has changed. In many cases, there is not a major upgrade or update to the protection required. So maybe adding the sync check or something like that. If there's strengthening required, then it's more likely that you're also going to have to update the protection. Of course, with strengthening, you have to go through the procurement process and then the installation of the new equipment. If the customer selects self-build, usually the self-build won't include the metering, although that is possible. Big reason there being that most of the distributors have the meters that they are going to install, and that already works with whatever other systems they have on the back end. So metering typically would stay the responsibility of the distributor, but you can specify which specific meter needs to be used, and that becomes part of the self-build agreement. So if you do the self-build, then the distributor's responsibility is to be part of that construction process, especially the quality assurance as far as possible. So whoever does the physical construction, review any type test certificates, any of the other acceptance testing certificates, and be part of the whole process. So similar to
Gerard, we lost you there. Not sure if it's only with me.
Yeah, I think he's
Gerard
yes.
is lost.
He's lost. Yes.
Yeah.
Hopefully only his sound is lost and not him. Let's just see.
Yes, the sound. Sorry about that.
That's stress. So he's still there.
I'm just going to add a comment while Gerard is somewhere in the ether. We had an interesting chat to Dixel and Buyisa, who do a lot of grid impact studies, and they were saying very, very seldom can't the network handle the applications that are coming in. So even with larger generators, he was saying, by far the majority of the time the network can handle things and there aren't needs for upgrade, strengthening, etc. So a lot of the time what we're covering here won't be applicable. It'll be a fairly simple, straightforward process. But this training obviously goes into a lot of what might happen if the network can't handle it, or if there, is some additional work to be done. But a lot of the time it'll be easy, straightforward, and what Gerard is talking about won't necessarily kick in. So I just wanted to give that comment. Gerard, you appeared for a microsecond, then you disappeared again. I'm not sure, but we did lose you for quite a while there.
I'm sorry, I'm now on the third option for Wi-Fi, so I hope Vodacom is more stable.
Okay.
Can you hear me?
Yes, we can.
Okay. So apologies for that. Let me just get where I was again. Okay, I think at the bottom part here, I was just saying be part of the quality assurance process all along. And Mark, I did hear at least a big part of your comment. Yes, at this stage, there is, I think, enough capacity on most networks that it's simply changing out the metering, maybe a little bit on the protection side, just making sure that everything is up to spec. If I think some of the older installations might have lower rated breakers, for instance. And now I'm probably thinking small scale, but the house in Germiston where we used to live still had a 2.5 kA main breaker. And I think the standard nowadays is to go up to 6.3 kA or something like that. So maybe with old installations, the breakers might not be rated for higher fault levels that had already occurred. So those kind of things. And so get used to the whole process. And when we get to all of this, where there's probably asset upgrade or additions or self builds, that should hopefully, you should have at least more comfort with the process. Does that tie in with what you said, Mark?
Yes, yes. Of course, people need the ability to handle things if they get more complicated. But there is a fairly good chance that, as you say, for a while, until the network starts getting more congested, it will be a fairly straightforward business to accommodate these generators. So I agree with you. Yeah.
Okay, I just see there's a comment from France popping up, having check meters on both sides. And then your metering VT and CT meter should be the same for billing and check. Yeah, I support that. We haven't actually spoken about any check meters or so, because that's policies in terms of your accuracy, and I think it's NRS 074. I might be wrong. Then there's another comment: enough capacity, is it directed to transmission type or distribution? And if in distribution, what levels, MV or LV? Mark, do you want to comment on that?
As far as I remember the discussion with Dixel and Boyisa, it was not the transmission they were talking about, but the embedded, which would have been on the distribution side, and I think both MV and LV. It was a generalization based on all the studies they were doing. So I think it's probably you can transport it as you can make that generalization for municipalities, but you are going to get some circumstances, of course, where the network doesn't have the hosting capacity. But it was just in terms of what you can expect. Most of the time, it seems like at the moment, it'll be a fairly simple process.
Okay, so my gut feel is that anything up to 5 MVA, the network in at least the metros and the bigger municipalities, yes, I fully agree with that. Above 5 MVA, I would just keep my eyes open. Okay, yes, we see your comment, so I think that's an admin comment, Ratayane. So let's just set the next, no, it's coming. This part was still on the distributor part of the construction, where we've just had a long discussion that hopefully a lot of this is not yet required. Then on terms of the generator construction, that is, the distributor has to allow access to the connection point for that integration, equipment, installation, and connection. So that's the key part. If they bring their connection equipment onto your property, you have to make sure that they have that access. Similarly, if you take the connection equipment to their property, then they have to give you appropriate access. Then it's important to review the installation of that integration equipment. And once again, it's maybe good to have whoever is your specialist in doing those kind of installations, the protection, any communication integrations, the electrical hardware as well, have them part of it so that they can just get an idea of what is going to happen. Because it's very easy for an inexperienced person to get some of these multitude of wires mixed up, for instance. And then witness the key points during the construction. That would typically be foundations, those kind of milestones in terms of the construction process. Then for the generator, I wouldn't want to say too much. It's really, they have to procure the equipment and continue with the construction. So equipment and material. it is their responsibility to ensure the quality assurance. So for their plant, once again, like we said this morning, you don't have to look at any of those quality assurance. Only aspects that could affect the safety of the network or other people on your side of the network. The safety on their side of the network is their responsibility. And you can have discussions with them, but you don't have to check that. Then with the strengthening and the self-build selected, again, they have to do now the procurement and the equipment and material and the construction similar to their own plant. But now they have to give any type test or acceptance testing certificates to the distributor to review. So what is the acceptance testing? Well, those are tests and quality assurance processes to prove that the equipment is fit for purpose. So that's, in essence, I'm bringing in this relay. I bought it off the shelf. Is there any out-of-box failure? And is it actually the correct relay or the correct breaker or even a transformer? So there's just a list of some of the more common tests. Factory acceptance testing. That is very often with transformers and similar devices where there are tests that's being done at the factory store to ensure that, or to prove that it meets the technical specification for that part of equipment. Then once equipment arrive on site, there are some site acceptance testing. These are standalone tests to make sure that the equipment is still functioning. Once again, taking a transformer as an example, it's been tested at the factory. You know that the winding ratios are correct, any tap changes are correct. It can handle the correct current. The short circuit and open circuit tests showed that the parameters are within acceptable ranges. And when you get to site, there are a few of those tests that you are going to repeat to make sure that there wasn't any damage done during the transit or the delivery process. Site integration testing is where you start bringing some of the pieces of equipment together and integrating them and going through the processes to make sure that they actually work together as well. Then type testing, that is something that's done in a laboratory. That's got nothing to do with the factory or the site. And a good example of that is the NRS 097-2-1 type testing for inverters for small scale levels. That's done in a laboratory according to also a set of rules, typically in a standard. And that laboratory is certified in terms of ISO standards. I can't remember the standard number, I'm sorry. But they have to be certified that they use correct equipment, correct processes, etc. And that then gives you at least some peace of mind that any equipment that's manufactured in the same way will meet the requirements. Some of these tests may actually form part of the pre-commissioning or even commissioning tests. So from construction until everything is done, there needs to be a continuous quality assurance process. Now, if you have somebody who's used to construction, they do lots of these projects, they would probably have their own internal policies and procedures by which they do this in any case. It might be worthwhile, but you also probably have it, is when you put out tenders for people to do these projects, is to ask them to submit their quality assurance processes. And at least at this stage, we can also have a look at it in the support program. Okay, so the distributed network assets, the process is basically, we've discussed it, it's similar to what we've discussed, it may be outsourced. If they self-build, the quality assurance clerk of works would typically sign off on that self-build as if the distributor has done the construction themselves. The key aspects, standards and processes is also, it's advisable to add that to the connection agreement. And once all of these things have been done, anything that the distributor had to construct and it's gone through the tests, notify the customer that at least on the distributor side, the equipment is ready for the next phase, ready for commissioning, etc. Generator assets with the integration equipment, just make sure that there is proper alignment and cooperation with yourselves as the distributor. So for me, the take-home messages on construction is that the distributor typically would have the metering protection and follow existing processes. The generator has to procure all and install all their equipment and take special care of the integration equipment, integration point. On terms of that integration, access for both of the parties to the other's equipment is very important. And that just links back to the cooperation. Self-build quality control remains the responsibility. The distributor has to sign off on the quality. So for that reason, as I participate in the project as far as is feasible with whatever quality process you have in place already. And then at the end, that self-build equipment that was built by the generator becomes your property. I think that's the key point, which we also had a discussion about yesterday, is if it's poor workmanship or anything else, you are going to sit with the problems later. That's why make sure that you participate and have the checks that you would have done even if you did the construction yourself. Because that's not, I think, too difficult, because most municipalities have some process to do the construction already, and I assume that many would outsource it in any case and hold the contractor responsible for the quality. That's fairly standard practice to have that in the contracts. So any questions or comments here? Nothing. There's people falling asleep already.
No, it's Friday, Gerard. While we're waiting for comments or hands or questions, please, ladies and gentlemen, engage us if there's something that was not clear or you wanted to add on what Gerard conveyed. But while we're waiting for that, Ratajane, thank you for that proposal. I think obviously if we could have finalized or end earlier, that would be great. But as Ishmael indicated, there's a few people that need to go to the mosque from 12:30, so I think we will stick to the program as is and rather see if we could start with the afternoon's work earlier on. So let's see if we could do that.
Yes.
But thank you for the proposal. Yeah, any other comments, questions, requests? I think it seems like it's clear, Gerard. Would you like to apply the checklists 6 and 7, isn't it?
Okay, 7 is still coming.
Okay, good. So you're gonna continue. Okay, then it's fine.
Yeah. So step 7 is the commissioning.
So
Now-
Rachel, you want to I'm just thinking of the recording. Can't remember what we agreed upon. I think it's part of the
No, I
lesson.
think,
So
yeah, so we can continue. This is one lesson.
thank you.
Okay, commissioning is actually the process of testing parts and putting them together until you get to the point where you say, okay, everything works together. So there's typically pre-commissioning. I think it might also be called the cold commissioning. But this is where you start with each piece of equipment and once again refer back to the discussion we had of all the acceptance testing. That is already part of the pre-commissioning, making sure that equipment works. And you might have done, for instance, with a transformer, site acceptance testing when it arrived on site, but you would again do similar tests once it's physically installed, even before you start connecting the conductors to the terminals. Now, during
Sorry, Gerard, by
Yes.
you, do you mean, you don't mean the municipality, huh? You don't mean the distributor when you say you?
No, I mean the distributor, sorry. Well, actually, whoever does the construction and who's responsible, that party should do these pre-commissioning tests.
Okay,
Well,
thanks.
that's part of the, so thank you, Mark. Now, depending on whose equipment it is going to be at the end, whose assets it will be, if the generator does any self-build, all relevant test reports and certificates have to be provided. And in terms of safety aspects or network performance aspects, the generator should also submit those type tests or other test reports, certificates to the distributor. One example would be, especially for the smaller than 5 MVA, where power quality still links back to the NRS 097-2-1 requirements, submitted type test reports. That's part of the, probably part of the application already, but at this point it becomes critical that it is available. The distributor will then, especially on the safety aspect, say, okay, we are comfortable that you've checked everything on your side, that this plant will not negatively affect the network or cause any unsafe condition. So that is then, we've looked at what you've submitted and we accept that. And that now you have permission to continue with commissioning. Now, once again, I don't say go through everything and say, but you've missed a point here. Especially with the bigger plants, there will be several professionals involved in the whole process, and they will sign off that they've done the tests. If they've done that, continue. Once again, unless you see, especially a safety issue right at the beginning, then they can start with a commission. So here's just a list, or some bullets of some of the typical pre-commissioning tests. And like grounding and bonding checks, that's applicable to any type of generator. Did they implement the grounding or the earthing as was planned? Cold loop checks is to make sure that you've connected wires where they were supposed to go, because that's something that easily gets confused. Have they done that? Well, that's part of the pre-commission, double checking that. Mega tests, that's to make sure that insulation is at the appropriate levels. DC voltage and polarity, and that's not just PV. Your protection equipment often have the DC power supply. Those kind of DC voltages also need to be confirmed. hot loop checks are when you start testing the functionality of equipment. And of course, AC phase rotation checks is always a good idea before you connect to a 3-phase supply. I just want to make sure that everybody can still see my screen.
Yeah, we can see it and we can hear you. It's all clear.
Yeah, we can see it. Yes.
Thank you.
Okay,
And
thank you.
just to confirm, Gerard, that what you're talking about now is not what the distributor does. This is pre-commissioning, which is done by the generator, by the developer. Is that right?
Thank you, Mark.
Yeah.
This depends on whoever has done the construction. So if the commissioning is, we're discussing as a overall process, and it's not just applicable to either party, it's applicable to both, but it depends on who's done the construction. So if the distributor had to add another transformer, etc., whatever is associated with that, they will do similar checks to this. But this definitely applies to the generator, because they've definitely constructed something that's going to need most of these. Okay. With one example in that's
Sorry, Gerard, there's a hand.
okay.
Manalisi.
Yes.
Yes, thank you, Chair. Yes, Chair. I think on this pre-commissioning, the testing tools that you use, are those the only ones I see? It looks like a multimeter and the loop impedance tests. Are there any other test equipment that you normally use to do those tests?
Okay, no, I just added a few pictures there to make it a nice slide.
Okay.
We didn't add a list of the equipment that's typically used, because for the distributor, you would have your processes in place, and the generator should also have somebody who knows what he's doing to do that.
Oh, okay. Oh, that's fine.
So this is just for pretty pictures. Thank you.
Yeah, Gerard, if I can maybe just add.
Yes.
For the type of test the utility or distributor needs to do would be linked to standard tests that you would do in the field. So utilities will not be involved, for example, to check the insulation resistance or the earth continuity on a solar PV plant. That's something that they need to do, and they need to have that equipment. So no specific or different specialized equipment needed from a utility perspective. In my view, it might be that the guys in the field experience it differently, that they had, for example, needed to start testing and measuring DC leakages or harmonics or whatever, but that's where your power quality measurement would kick in. So that might be a different type of metering that's necessary, but it's more constant monitoring purposes than a once-off commissioning test. Gerard, you can maybe just confirm if that's the case.
Yes. So if I still haven't put it clearly, that's also what Mark had asked. So whatever is going to be the generator's equipment, he definitely constructed that or had somebody contracted to do that construction. That's their responsibility. So you are not going to make sure that anything is fine on the PV plant. All that the distributor would be concerned about is their assets. Doesn't matter who constructed it, but the assets that belong to the distributor after this process is concluded, and the integration equipment. Those are the critical ones. Now, whoever built the integration equipment would do the pre-commissioning, issue the test certificates or test reports, and during commissioning, it would be advisable for the distributor to have somebody witness the commissioning tests and making sure that it goes through a rigorous process to make sure that there aren't any signals that's connected incorrectly again. So typically set up a set of tests, and that depends on what's being commissioned. So I don't have a good range for that. But let's talk about that commissioning a little bit later. So pre-commissioning, whoever did the construction does the pre-commissioning as well. Issue the test reports and certificates before you can continue to the next stage of commissioning. Okay. Is anybody still unclear on that? Don't see any responses for it.
Looks good. You can continue. Thank you.
Okay, I do have an example or just here for transformer checks, because transformers are relatively expensive pieces of assets. It's a good idea to take oil samples before and after energization, for instance, as well. So that's part of the pre-commissioning. And you first test the transformers inside or in situ. And after it's been energized, there's another round of tests. And you can very often, this comes from Prof. Jan de Kok, who's got a lot of transformer experience. You might pick up that there is some internal problem, maybe a hot connection or something, and you will probably see that fairly quickly in oil samples. Plus, the next point is that you now have a fingerprint of this transformer's performance, and that's why you do all of these tests during pre-commissioning, so that when you do any tests in future, you can see how is this transformer aging. So protection relay testing, of course, there's the injection testing to make sure they work. Interlock verification, that's important in a safety, from a safety point of view and a network security point of view. So that definitely involves both parties, both the distributor and the generator. Battery discharge tests, that's in essence to make sure that there aren't any bad cells in the battery or something, but that would also be the generator's responsibility. Unless it's for the protection, then it becomes the distributor's concern. Okay, grid code compliance would also occur. Some of the tests can basically occur along with the commissioning, but they would usually occur after commissioning. But some of the grid code compliance aspects can be checked during the commissioning, so that you can already see this control setting is wrong, so fix it during this commissioning process. So that was pre-commissioning. Now we get to the actual commissioning. You've got the permission, or the generator has the permission now to continue. If it is the distributor's assets, the project manager has given the permission to continue with the next stage. So in that case, project manager or the distributor would have looked at all the necessary test certificates and reports. So yes, everything seems to be ready for commissioning. Yeah, I see there's a question from George. What about battery charging tests? Specifically where there's a limit on charging capacity. Is that referring to basically the impact on the distributor network?
Yes, that's correct.
Okay, I would do that as part of the commissioning test. So that's similar to, we'll get to that just now as part of the commissioning. What would the distributor specifically check? And just remind me if I don't say anything about this again. All right, then You've got all the document, well, yeah, as part of the commissioning, all the documentation that we have spoken about this morning, like wiring diagrams, system data, that should all be available when the actual commissioning takes place. And this is now the two systems gets connected together because you've checked all the subsystems and you know that everything works on the distributor side. So whatever new assets were constructed for the distributor, you have confidence that it will supply power to the new customer or be able to absorb the power that's coming from the generator. You've checked that all, and the generator is sure that it will be able to generate as per whatever, whether how much sun there is, how much wind, or whether he's got a biodiesel that is running. That is also fine. Now you connect the two together. So before you can do it, also make sure that all relevant documentation is available. Where required, this documentation can still be updated. So for instance, if there's a wiring diagram that's incorrect, if you pick it up during commissioning, make a markup and have the as-built drawings added afterwards. And that again applies to both sides of the commissioning process. So for the distributor specifically, but I think what is important for the distributor to confirm during the commissioning process is that the anti-islanding does work correctly. And that's a basic safety check and just a system performance confirmation. You can also double check that that sync check, for instance, is working correctly should the anti-islanding fail. Next up is the feedback limiting. So whether you set that at 0 export or have an upper limit, and we haven't really discussed that, but it's of course possible to, if you have, for argument's sake, a 2 megawatt plant, and the point of connection, the NMD, was 1 megawatt, you can ask them to never feed back more than, let's say, 1 megawatt into the system, because that's what your assets can accommodate. That has to be checked and physically tested. So try to feedback more than that, then confirm that there's nothing there. And the safety aspects, that's one of the key concerns. So that should be taken care of by the certificate of compliance on both sides. If there's LV assets on the distributor side, you have your processes of having somebody sign that off. And the clerk of work should also sign off on the safety with whoever support he has from safety staff. And similar to this feedback limiting, George, your question, you can ask them to demonstrate that the battery is never going to charge faster than X due to a limit on your technical side of your network. So if that is what you would like to confirm, you can add this to this part of the step. Okay, Franz, you've got a certificate of compliance for LV, safety report. Yes, that's 2 parts of the COC. And yes, on the medium voltage side, yeah, they are also the safety processes. Thank you. Do you want to comment on that, Franz?
Yeah, just quickly, I think, seeing that this plant can be LV and MV intertwined. So definitely when we start talking about transformers, etc. and so on, then there's an MV component. So the COC is then the LV part for as per SANS 10142 part 1, and then the safety report is for then the SANS 10142 part 2's because that is actually seen as the COC for the MV. Thank you.
Okay, thank you for that clarification. Yes, Frans. Okay, so in terms of the commissioning, I think I've got the wrong slide here. So just summarize the commissioning part as well. First, the pre-commissioning. It's a responsibility of the party who did the construction or contracted the construction. So the distributor's assets that he physically had the construction done or contracted becomes his responsibility to make sure that all the relevant pre-commissioning tests and then integration tests and then the commissioning tests are done on that equipment. For the generator, all of their plant that's going to remain their property, it's solely their responsibility to go through all the tests. For there, it's also required to add the grid code compliance so that they at least are ready to do the grid code compliance after commissioning has finished. The self-built options, in my opinion, it would be very important for the distributor to become involved at the pre-commissioning level, at least to make sure that all relevant tests and tests are done, that the test reports and certificates are issued and verified. Once again, remember that self-built assets becomes your property, and it becomes your problem if there are problems. So make sure that the quality assurance is done properly. The integration assets, that is very important, that both parties cooperate. Make sure that there's alignment between how they interpreted everything. And that is also done via proper pre-commissioning tests and then the commissioning tests, and definitely both parties being in attendance when those tests are taking place. But any questions here? I think we had quite good discussions through the discussion. So step 9, that's probably the easiest one. That's just making sure that everything has been done, all documentation has been received, and everything is there. And then you can issue a formal closeout to the customer. And what I wanted to just highlight here, we've got the checklist, so we can go through the checklist again. But so network assets have been constructed to their standards, that we've all checked, we've discussed this. Necessary agreements are in place. NERSA registration or licensing completed. The commissioning report complete. So whatever has been missing, there can be several stages to this. Grid code compliance reports have been submitted to RETEC. Is there a letter from the grid code secretariat that they are satisfied with all the grid code requirements? Now that's the one thing that I think we'll have to, that's a problem, because we suspect that RETEC won't be able to have a good enough turnaround time on this. So the proposal is that if the responsible engineer or professional has signed off that the grid code compliance has been achieved, and that means also that the power quality has been signed off by yourself, you can basically, that's a written permission for commercial operation, but that can be a conditional permission. There's nothing wrong with that. Say, well, it's conditional assuming that everything is correct, and RETEC gives their final approval when they do. So this is just to make sure that plants don't stand idle for years until RETEC can get to that. Then all the environmental and other authorizations, that's also being checked. So the checklist. Or sorry, I can't see my second screen at the moment. After load shedding ended, let's not come back on.
You want me to share the checklist?
Maybe yes, please.
Okay. The document one, right? So not the internal one that we're using. Okay, sure. Which section do you want to go to?
Section 6.
I'll do that for you.
We can just scroll through there.
There's a question from Naeem. I don't know if you saw it, Gerard. You did talk to it, but I think it could use emphasis.
Okay.
Good question, Naeem.
So is the generator allowed to put the plant into operation without the approval letter from RETEC? Well, obviously they have to do commissioning. And okay, we'll talk about the grid code compliance process after T. But yeah, I think the key part is that as a distributor, you are comfortable that in the first place, there are no safety impacts on the network. In the second place, there's no technical problems with the plant. So as long as the plant can safely and appropriately interact with the plant and generate, then I think they should be allowed to connect and actually operate commercially. RETEC does it with temporary exemptions all the time. Well, not all the time. If you've got a valid point that you don't have your approvals yet, you just apply to NERSA and you say, listen, I've done all of this, I've submitted it. I haven't received the feedback. I want to continue operating. I don't even ask for a temporary exemption with anything except the fact that I don't have the approval from RETEC. So there is a process for that.
So
Okay.
am I correct in saying then your recommendation is that a temporary exemption from NERSA is obtained before full permission to operate commercially is given? Or would you say earlier you didn't mention that sort of temporary exemption?
Yeah.
What's your situation? What's your thought, Gerard?
I would allow them to operate with the provision that the RETEC approvals and NERSA approval is pending. You can also tell them, listen, just get it in the process. So we can talk about that with the grid code compliance. That if it's submitted to RETEC and there's reasonable assurance that everything is fine, I don't see why RETEC or NERSA should hold this up. The big IPPs, in my experience, they connect, commission, and start generating because if for nothing else, they need to do the power quality assessment, which is part of the RETEC process, whilst they're already generating and operating under normal conditions. They can't do that just during commissioning. So there's an automatic temporary exemption for, I think, 6 months to get the power quality sorted out. RETEC in the past, and that's now the grid code compliance part, in the past they attended the grid code compliance testing and then said, yes, they are happy with that the plant is compliant, and they will only finally approve it once the reports are submitted. But as far as I know, none of the plants have been told they must stop generating especially not because of questions on the whole process.
Thanks, Gerard.
Okay, Fora, I don't think you've got the correct sheet there.
I can check.
No, that's a very old one for you're on
Yeah.
some earlier version.
Sorry, open the wrong document. Let me just get the right one.
Imran, you mean does Eskom allow generators to operate without approvals from RETEC? Or can you just clarify your question? Yes, I'm not aware of Eskom switching off any of the generators at this stage, especially not due to RETEC delays.
Okay, thanks.
The big thing is if there's a negative impact on the network, let's say power quality becomes a problem, or there's some other safety issue that the protection didn't operate correctly, then you can start saying, listen, I think you should disconnect, or tell me how you're going to fix this in the short term, not when you get to installing a filter or whatever. There are other aspects like the low voltage ride through where plants tripped when they shouldn't have, and they don't get stopped for that. Maybe once we've got a very strong and stable and reliable grid again, and we don't have load shedding in the back of anybody's mind, then we can become more strict. But for now, as long as there's reasonable assurance that everything is fine, I would allow them to connect. Okay, so we with construction and commissioning.
There you go. So
Is
it
it
starts around. Okay, I think this is where we started.
the design we did yesterday? So it was the top. There we go. Stop.
Good.
Yes. So in terms of the checklist, it's not a lot of checks for the distributor specifically. It's the metering equipment, have they been installed? If there's any strengthening, has that been installed, and has the upgrade or the protection been upgraded? I think the strengthening should actually not be there. And then in terms of the customer or the generator equipment, have you seen any type test certificates or other testing documents? And have you attended any acceptance testing? Now, that would depend on what is important to you. Things like that would, for instance, be anti-islanding. But if it isn't, then it's not applicable. The same with the commissioning. We start with you have to issue the permission to synchronize. That's the permission to actually start with the commissioning. Have you attended it, specifically anti-islanding or other safety aspects and network technical performance aspects? Have you received all the documentation? And I think we've also said we are going to split this into the relevant parts. And after that, permission for commercial operation. And I would say just note in the comments, conditional permission has been granted based on evidence provided by the generator, if it isn't a full one. All right. Thank you, Flora.
Great. I see Gerard, what is up next?
That would be the grid code compliance.
Okay.
And that's, yeah.
Okay, so we've planned for a break until 11.